Hi everyone, welcome to the second of our webinars discussing how to unlock Data Vault. Just while everyone starts to join, I wanted to explain to you how you can participate in today's event. Now you can listen using computer audio, but if you're having any issues with that, you can connect via telephone. Simply expand the audio option in your GoToWebinar panel and you'll see how to do this. Now it's going to be a very short but information-packed webinar. We've got about 30 minutes, so whilst I will be monitoring question and chat panels, we will probably not be able to provide many responses during the session. However, please do log any questions. It's very important to do that, as we will answer as soon as we can during the course of today or tomorrow, either by chat, by email, or we'll contact you by telephone. And lastly, I just wanted to let you know that this session is being recorded, so we'll share this with you via email and you can listen at your leisure. So my name's Donna Cooper, I'm from Warescape, and I'm delighted that we are again joined by Michael Olschenker, who is co-founder of Scale Free, and Mark van der Heide, who is Senior Solutions Architect at Warescape. So last time in part one, we gave a brief overview of automation and we described who benefits and how. We went through these 5 Ds of automation and highlighted the importance of automation in ensuring consistency. It's especially relevant in a data vault environment where you're building hundreds of thousands of objects. Our attendees also saw a Warescape product demonstration, which gave a brief preview of design, development and documentation automations. That was 3 of those Ds. And our focus that time was on loading raw data into Data Vault. This time we're going to focus on getting data out. By the way, if you didn't receive a copy of the previous webinar and want to get up to speed, let us know and we will send this to you. Before we start today, though, I just wanted to remind you, Warescape is very closely linked to Dan Lindstedt, who invented Data Vault back in the 90s. He's continually refined that framework since then. And this actually leads me nicely introducing our friend Mike, who co-founded Scale Free with Dan. Today, Scale Free is active across Europe and specialises in Data Vault training, consultancy and projects. So Michael, I'm going to hand over to you now so you can continue on our journey describing the value of automation when delivering Data Vault.
All right, perfect, Donna. Okay, so sorry about that. Okay, so there you go. So today's presentation for us is essentially focusing on both the patterns of how we load the Data Vault, and then also how we derive the useful information, actionable information for the end user from the Data Vault model, essentially. And before we dig deeper into the patterns and into all the details, first of all, Data Vault 2.0, the way we define it, includes 3 + 1 or 3.5 pillars. One is the model. That's the first part, the lowest part here. The model link part, the hubs, links, satellites, as you know them. That's one piece of the action. It's one pillar or one component of Data Vault 2.0. It's a very flexible model, so we can extend it over time, for example. It can deal with any volume of data, both large data sets, but also very small data sets. And it's been derived from nature without going to too much detail there. So that's the hub and spoke design, essentially. Then we have the architecture. That's a multi-layer architecture, again, scalable. It can scale it across multiple environments into the cloud, on-premise. It can integrate across different regions, different organizational units, and so on. And it also supports NoSQL environments. We can integrate, for example, document stores, JSON doc collections, for example, Hadoop clusters. We can integrate in-memory stores, and so on. And then the methodology, that's essentially based on consistent, repeatable patterns that we execute with every iteration of the project. And using these patterns, we can essentially improve the development processes over time. There's a continuous improvement essentially embedded here. And part of the methodology, we consider the implementation as a sub-pillar or a sub-component of the methodology. Why? Because in Data Vault 2.0, everything is agile. Everything is about delivering business value in an agile fashion, step by step, with every sprint, every 4 weeks, our goal is to deliver some new business value. And the end user defines business value as having a new report or having a new dashboard, or at least a piece of a new dashboard, a piece of a new report. To support this approach, this agile approach, we use the implementation patterns in Data Vault 2.0. The implementation patterns are essentially define how we load staging areas, but also how we load hubs, links, satellites, all the special entity types, and so on. Also, how we derive information from the data vaults, all pattern based here. All right, so let's take a look at these patterns, because the great thing is when we load the data warehouse, an enterprise data warehouse here, there's a series of steps to be done. The first step is getting data into the staging area or into your landing zone. That's the first part. That's based on very simple ETL, which we can essentially generate based on metadata. The second step, once the data is made available in the staging area, we can essentially, what I like to say, creatively break the data up into its own pieces, into the business keys, the relationships, and the descriptive data, loading all the raw data into the raw data vault, again, using very simple ETL. 3 lines of code essentially being generated in SQL, again, generated on the very same metadata as for the staging area. And then once the data is integrated, versionized in the enterprise data warehouse layer in the raw data vault, the next step is to essentially apply the business logic on top, or in addition, essentially to the raw data. We use what we call the business vault for this concept. That's where we implement the enterprise business rules essentially. And then, but still the business vault still follows the data vault modeling concept. So we still talk about hubs, links, satellites there. There might be we call them computed satellites, exploration links, business hubs, but still they follow the same modeling techniques. The cool thing about that approach is that once we have the business rules, or actually the results from the business rules modeled in the business vault, we can now join both the results from the business vault, but also the raw data, join these data sets or these entities in order to produce the information marts. And the information marts, that's really the end user defines the structure and also the content of the information marts. So they will tell us, we would like to have a star schema or a snowflake schema, flat and white structure with the following content, essentially, with the following attributes, the following measures, dimension attributes, and so on. And the way we can essentially derive the target, the information marts, directly from the data vault model, from both the raw vault and the business vault. But for that, in order to have a high performance on that, we will need PIT and bridge tables. And today's show is all about, it will also show how to produce these PIT tables, for example, in RESTgate. All right, so let's focus on the first part, essentially getting data from the staging area into the raw data vault. And for that, we have essentially very highly optimized patterns, loading patterns, how we get data from the staging area into the raw data vault. For example, loading hub, the distinct list of business keys in the data vault model. The idea is to identify unknown business keys, new business keys, so far unknown to the raw data vault essentially. And the data is in the staging area. The data has been hashed already. Hash keys have been computed last time. So in this step, it's all about identifying new business keys from a staging area and loading them into the target table. We're done. It's 3 lines of code in SQL because it is as simple as that. So if business keys are known by the target, we can essentially drop them from the load. If they're new to the target in this lookup, they will be loaded into the hub and we're done. Very similar approach for links. The link is defined as a distinct list of relationships between business keys, which means that we are identifying the relationships from the staging area, check in the lookup if we have the relationship already in the target or not. If it's already in the target, we can drop the record because we already know the relationship. And if we don't know, if the target doesn't know the relationship yet, we can load it into the target table essentially, and we're done. And then for satellites, this is all about identifying new deltas, changes to the source data, which exist in the staging area, but not yet in the raw data vault satellite. So what happens is we retrieve a, again, distinct list of the source records from staging area. We identify for each parent. So for example, let's say the staging area records describe a customer. We need to find the latest description of the customer in the target satellite, and then compare them. Compare both the staging side with the raw data vault side, the source with the target. If both sides match, if the descriptive data in the raw data vault satellite matches the data in the staging area, that's not a delta. We're not interested in that because we already know this description, so we can drop the record from the feed. If something has changed, one of the descriptive attributes have changed, the first name, last name of the customer, in that case, if any column has changed, we load the record into the target and we're done. To improve the performance of the delta check, we could essentially compare column by column. Typically, in many cases, we use what we call hashdiff. Essentially, that's improving the performance of the delta check in a sense. What's gone is what we call the load end date. Nowadays, we don't need a load end date anymore. It's an insert-only technology. We use either a window function, lead or lag, or the max load date function, or we use a pit table that's pointing to the latest deltas in the parent. Just for the cracks out there listening right now, that's the solution how to get rid of the load end date in a sense. All right, now the issue is, or a challenge now is, we got the data in a raw data vault, we loaded the half-swing satellites, but then what's next? So the end user, to be honest, doesn't care for having a data vault. What they would like to have is a dashboard. And for the dashboard, we need some structured model, some star schema, snowflake schema, flat and white structure typically. And that we have to prepare now, essentially by deriving the dimensional models, for example, from the data vault. On a traditional database, we might now get into performance issues because when you join data on a, let's say, Oracle database or some SQL Server database or something, in that case, we will see that even in a simple case, let's say we got a couple million records in a hub, a customer hub, we got 2 or 3 satellites attached to the hub, we will run into performance issues in Data Vault. Not because, what a lot of people think, not because of the number of joins. It's not the number of joins that's killing the performance. The problem is the complexity of the joins, because what's required is a left join, essentially, a left join with a between query, with a between condition for producing type 2 dimensions, SCD type 2. That problem is super old. The first Data Vault had these issues, so Dan Lindstedt solved this problem back in the 90s, even in the original context, which means that we already had and always had what we call point-in-time tables. And a lot of people look at these tables and they get, let's say, they struggle with this. But to be honest, a point-in-time table is easily to be generated by Wirescape, by the generator. So these tables will be generated, and it's just the usage that's a little bit different to the previous pattern. What happens here is the pit table is an index into your satellite deltas. It will tell us for every customer, or in this case passenger, for every passenger and for every what we call snapshot date, what is the most recent delta to be used for that particular snapshot date. So let's talk about a snapshot date quickly. The idea is, the idea of a load date is that it identifies the batch of data coming in. So we use the load date in the staging area to identify the batch of data. We use the load date in the raw data vault, for example, to identify the delta in a satellite. So the load date identifies when data comes in. Let's assume data comes in real time. So we get near real-time batches or real-time messages coming in. You get data. You have a data inflow all the time. Your end users, what they would like to have is, even though the data is in real time, they might have the requirement, and many have this requirement, to have stable reports for a while. They would like to have, let's say, they pull a report in the morning at 8 o'clock when they come to the office, and this report should remain stable until the next morning, even though the data runs in or is being loaded in real time. They would like to have some stability. They define the stability. They may say it's a daily report. They might define it's an hourly report. This report should be updated every 50 minutes, should be updated every 5 minutes, or every second. But they will define how often they will update. They want to have an update on the report or on the dashboard. And that's driven by what we call the snapshot date. Ideally, what the end user wants is they would like to freeze the whole enterprise data warehouse, all the data in your enterprise data warehouse. They want to freeze it, create a snapshot, and report on this snapshot of data. This snapshot is identified by the what we call snapshot date. That's a timestamp. Don't get confused by that. Could be, for example, the 1st of January 95, 8 o'clock in the morning. Every day they want to create one snapshot. So it's on a very regular basis. Every morning at 8 o'clock, you're creating one snapshot, freezing all your data. And the PIT table, the point in time table, implements this snapshot essentially. The idea is I need to know for a given snapshot, this morning, for example, I need to know what was the most recent description of the passenger in all of my satellites. In this case, we've got two satellites here. We got the passenger name satellite and the preferred dish satellite. So I want to know for the snapshot date of the 1st of January 95, what's the most recent description for passenger with hashkey 84 whatever. What's the most recent description on this particular date for this particular passenger in every satellite? So this one says essentially there was a delta from June 26, 91. That's the most recent delta to the 1st of January 95. That's why we activate it in the index. The index points to the most recent delta. This delta is still active on the 1st of January 2000 because there was no update in the source system. We haven't received any change from the source system that we could activate here. The issue is if the satellite doesn't know the passenger because it's not known yet, for example. In this case, we're activating a ghost record, essentially one record in each satellite that provides us default values, and it guarantees us an inner join with equi-join condition on the PIT table essentially. So when we use this PIT table, we can essentially join all these satellites instead of using a left join with a complex join condition, snapshot date between load date and load end date. We use an inner join with an equi-join condition, and that's typically on most, if not all, database systems, relational database systems, it's the fastest join you can get. And then it doesn't matter anymore that you have 5 or 6 or 10 joins, inner joins, as long as you avoid these left outer joins with complex join conditions. That's the issue of information delivery. All right, and then once we have the PIT table, the point in time table, the next step is to introduce derive a dimension entity from it. The dimension entity is, to be honest, not table, it's a view. It's an SQL view that virtualizes the implementation of the dimension. By using the PIT table, that guarantees us inner joins and equi-join condition, it will be so fast that you don't want to think about materializing your dimensions. And to be honest, I can't remember when I have materialized my last dimension or my last fact entity for the last time. It must be before Data Vault 2.0, before I met Dan, before we worked on Data Vault topics, that I have materialized my last dimension. After that, it's all virtualized. If you get a performance problem in Data Vault, you will have, before you think about materializing your targets, your dimension and facts, introduce PIT and bridge tables first. That should solve your problem. All right. I think I'm done. For my part, I would hand over to Mark to show you and demonstrate you how to implement these concepts in Warescape.
Yeah, thanks, Mike. So indeed, today is all about showing how to get the data out of the data vault. So that means we need the point in time tables that Mike just talked about. We need to have an information mart on top of that, virtualized or not. We don't really care at this point. So let's start where we left off the last time. This is if you've been watching the previous webinar, this is the model that we used last time, the logical model that is the basis in terms of metadata to generate a raw vault. So if you look at this is all pretty standard. So it's your logical business model. There's a source system mapped. And today we're going to take this model and say, what happens if, for example, I want to add some business logic? I want to add some enterprise business rules to my logical model. What happens when I have multiple source systems? what happens when indeed I want to get that data that I've all loaded into my data vault. What happens when I want to take it out of the data vault again? So we are picking it up where we left off last time. So I'll start with adding some business logic, some kind of attribute, and in this case, I think we'll pick the order detail, and we will calculate, for example, the order value. So we'll just go into the logical table here, into the attributes, and over here I can simply just add a new attribute, and we'll call that order value. Need to choose a data type, so I'll go with decimal, just the standard, and the attribute type that I'm picking here is calculated, because we're talking about calculated attributes. So that's one step. That's all fine. It should be nullable. That's a small detail. And the next step would be to add our business logic, add the transformation. So I'll do that here. I can call this order value as well, and point that to the attribute. So we'll take unit price and multiply that with the quantity. Quantity. So this would be our business rule implemented like this. I can have a description here as well if I like, and this can be put into the documentation. So this is typically how you could add business logic into your logical model. Now, just like last time, we can now generate a raw vault model out of this. And what we'll see that happens is, just like last time, the satellites will be split up based on the rate of change, for example. But in this case also, let's see if we can find it. This was the link order detail. Here it is. And we can see that right now there's a calculated satellite here for the order value. So this will hold our business logic. And in fact, there's another one because we have two source systems already. So this is now all generated for you. Of course, this could be an empty satellite without any logic behind it. That's also fine. Remember that this is all about modeling automation, automating a physical data vault model. And when we deploy this from WhereScape 3D into WhereScape Red, where that metadata, this whole model will be picked up, and code will be generated to create tables and to load all the data. This could mean that this satellite is not being loaded correctly yet. But that's because business logic, business complexities, that's the stuff you need to focus on. So that is the only thing that you're going to have to build manually, because this is not automatable. Automation is about repetitive patterns, and business logic typically is not repetitive. But the satellite is already there. So all you have to do is implement the logic, make sure that the logic ends up in the satellite. That's it. So you can really focus on getting that logic right instead of everything around it. And of course, just like normal satellites, the whole start dates and version numbers and everything, all the metadata that comes with a data vault is handled by WhereScape. Which actually also brings me to what Mike just mentioned about ghost records that are necessary for point-in-time tables. Those will be added by WhereScape automatically as well. So you don't need to worry about that. We'll take care of ghost records in satellites. So that is kind of how you could implement business logic. Of course, you could also choose to skip this whole step and just add your business logic into newly generated satellites using WhereScape Red directly, which would be just drag and drop stuff from your raw vault and in Red and create new satellites manually. That's also an option. So that's the first thing. That's what I wanted to show you about business logic. The next thing on the agenda for today is extending this logical model with multiple sources. And actually, this order detail here already shows it a little bit. If you've been watching closely, you can see that just like last time, most attributes have a source mapping to one single entity and attribute, but these, order ID and order line, for example, these have a number. There's a 2. And that's because we've added a second source mapping. So source mappings are our definition of unique, completely independent mappings from a source system into a model. So in this case, into your logical model. And what WhereScape will do is take, of course, every type of attribute and create separate satellites per attribute type, but it will also split per source mapping and even per source entity. So in this case, we've got Northwind that will hold data from employees and customers and orders and products and order details. But Eastwind, for example, that's a new source system, and I've just added an example mapping saying, oh, this is all I've got from this second source system. I don't have everything. So completely independent mapping. This will be handled automatically. So for demo purposes, I've prepared a very extensively mapped. So it's the same logical model here, and this model is now mapped to 3 source systems for most attributes. So if you look at discount here, this is only mapped to one single system. We can also have a nice overview and trace, kind of get a lineage diagram for the entire entity and see that, oh, Northwind takes 5 source tables, and then that is mapped into the order details. And the same counts for Eastwind and Southwind. So we can see all these independent mappings, and the model, the whole source mapping diagram is shown here for every source system. Now, it's the same thing. We make an advanced copy and copy it into a raw vault model. So applying the model conversion, and once again, just like I showed you the last time, it's the exact same rule set, but now we get a much bigger raw vault model, because let's say we have a look at the customer. So let's find the customer here and show that little diagram. So customer already has 5 satellites because we have the rate of change. So we've got low rate of change attributes from 3 source systems, and we've got medium rate of change attributes from 2 source systems. So it's been splitting that up automatically. Oh, there's another one here, obviously. So we've got 3 for medium rate and 3 for low rate of change. Apparently, we don't have any high rate of change satellites, so we've got 6 over here. Now, if we go to click through to the product has 9 because there are 3 source systems and 3 types of attributes. So we've got high rate of change, medium rate of change, low rate of change satellites for North, East, and Southwind. So it's automatically splitting all the data up so that we can do completely independent loading from all source data into this raw data vault. This is essential. You don't want to be required to join data together. We'll do that on the way out. Now the next step. So now basically we've got a huge, big raw vault model. And the next step would be, well, generating those point in time tables, right? And so how do we do that? Let's say I want to create a point in time table for this product. So in product, we saw that there are 9 satellites. It's a difficult job because we need the hash key from each and every satellite. We need the hash key from the hub. We need the load date from every satellite. And then we need to apply that logic to get the highest, so lead or lag, or the maximum load date from every satellite. So how do we do this in 3D? It's pretty easy. We have a table type here. So this table, the hub is flagged as the table type hub. But we can have multiple types. So in this case, I'll flag it with a P for point in time table. If I'm taking product, I can go ahead and take, for example, order, flag that with a P as well. And well, what else? Maybe the customer. That has plenty of satellites as well. So we'll flag that with a P, and employee, why not? So I go through the model. We can even automate this, right? If you say, by rule of thumb, every hub with 2 or more satellites, whatever, or every hub needs to have a point in time table, you can, of course, configure the conversion rules so that every hub will automatically have this flag for a point in time table. So I've put in my flags on 4 hubs. Now what I'm doing is the same pattern, same step. I'm creating an advanced copy. In this case, I'm going to my business vault. So I'm going to a business vault model, applying model conversions, and it says generate bit tables and bridge tables. Now bridge tables, we could generate them, but typically they are so dependent on how you get data from your data vault and the performance that comes with it. It's maybe not necessary, or it's maybe not automatable enough to create bridge tables, but we could. But let's focus on the point in time tables for now. So here they are. We've got one for employee, product, customer, and order. And so let's take employee here and see we've got hub employee. So that's the hash key from the original hub. And for every satellite from the employees, we have the hash key and the start date. Now again, I could go and show this in a kind of a lineage diagram, and it will show you where the data came from. So it's coming from these source tables, the employees table from each and every source system being loaded into the hub, and of course all the separate satellites that are being joined together into the point in time table. So it's still pretty straightforward. However, there is no logic behind it yet. We need some kind of logic for that maximum load date for every single satellite. So for that, because Red could generate that for us, but we want to have that over here already. So I'm going to make a deployment model for this business vault. And the deployment model will just isolate the point in time objects and generate the necessary logic that will then be transferred into RESCAPE Red and put into the generated procedures or any script that you want to populate these tables. So let's take employee again, same table, but now if we look here, all the code has been generated to get that hub and to create a left join on the satellite to get the maximum start date. And this is an example logic, right? You are in control of what's being generated, because this is all template based as well. But it's generated for you, and we can now simply deploy this model with only the point in time tables into RESCAPE Red, so that these tables are made physical on your data warehouse, and the code to populate these tables is generated as well. So this will take away the first big hurdle of getting data out of a data vault. And it's important to do this properly. It's not difficult logic, but once you've decided that this is the way you want to populate point in time tables, you need to make sure that there are no mistakes being made. So automation is key for that. This step, automating the point in time tables and the logic behind it, is essential, because now you can trust that the data that comes out of your vault is essentially technically correct, because the point in time tables are now influencing and in control of what data comes out. So finally, how do we now get an information mart? And it is actually the same way. So I'm going back to my generated raw vault model, and let's say I want to create a star schema. So I'm taking hub employee because I want to have an employee dimension. I simply flag it with a D, D1 for a type 1 dimension. I can use D2 as well for a type 2 slowly changing dimension, and just flag my hubs again. That will become a dimension. So I've got the same 4 ones: order, product, customer, and employee. Now I want to have a fact table as well. Well, facts are typically made out of transactions, maybe order details here. So a link can be defined as a fact. I'm flagging this link table to be the source of my fact table. And what I can do now is, again, just like last time, advanced copy. This time I'm going into the information mart model. So I'm building a mart. And what I would like to call this is a raw information mart. So this gives me all the attributes for the customer, all the attributes for the product, and all the attributes for employees, and for order as well. So order only has order ID, and all the transaction attributes for the fact. And this is kind of a raw information mart, because this would be a good starting point to sit down with your end user and say, okay, what do you actually need? And you can strip out the stuff that is not necessary, and you can start adding your business logic in here as well. And the way you would deploy this into your data warehouse is up to you. So you can indeed make this virtualized, or make it physical tables and have a procedure or some kind of script to populate these tables. That's up to you. It's just, again, very easy to see where the data is coming from. So fact order detail takes the data from the load table and 2 satellites. And all of that is coming from order details from each and every source system. Note that the load and stage layer is not in this model, but that's not important. If you deploy this model into RED, it will still map to your data vault, and it will still get out the data correctly. It could even automatically use the point-in-time tables to get that data out properly. So this is essentially a wrap-up. I'm seeing that we're already past the time, so I'd like to wrap it up here. Thank you for your attention, and if there are any questions, we'll get back to you as quickly as possible. Thank you.
That's great. Thanks, Mark. Thanks, Mike. I'm going to leave the webinar running for a couple more minutes. So if you have questions, please enter them into the questions pane. As I said at the beginning, we'll come back to you within the next 2 days. Everybody will receive a copy of this recording, and a few people have asked for a copy of the recording that we did last time. So I will be sending that to you as well. But thank you again for your time. Thanks, everybody. Well, I'm going to conclude the webinar now. We'll send the recording later. Thank you.